everyone, my name is Trishana Smith, and today I'll be speaking to you about the base 5 or quinary numeral system. Later on, you'll be joined by my classmate, Miss Moisha Morgan. What is the base 5 numeral system? The base 5 or quinary numeral system. The base 5 or quinary numeral system is a system with 5 as the base. There are 5 digits, 0, 1, 2, 3, and 4, starting with the power of 0 at the right digit and increasing to the left. Now I'll be showing you a placement value match of the base 5 numeral system. So it starts with 5 raised to the power of 0, 5 raised to the power of 1, 5 raised to the power of 2, and 5 raised to the power of 3. 5 raised to the power of 0 is equal to 1. 5 raised to the power of 1 is equal to 5. 5 raised to the power of 2 is equal to 25. And 5 raised to the power of 3 is equal to 125. Let us bear in mind that 5 raised to the power of 0 is always 1. 5 raised to the power of 1 equals 5. 5 raised to the power of 2 equals to 25. And 5 raised to the power of 3 is equal to 125.
Hello, and welcome to another Math Virtual online class. I'm Miss Morgan, and I'm picking up from where Miss Smith left off. So, as Miss Smith said, we're doing the base 5 number system. And another name for base 5 is quinary, and that simply means 5. And in base 5, we can only use 5 numbers or 5 numerals. Think of it like you're having a party and you only invite your 5 friends. And anyone else that wants to come to the party, they cannot come because they were not invited. And so you're going to think of your friends as these 5 numbers. So let's go over them. We have 0, 1, 2, 3, and 4. These are the only 5 numbers that you can use in base 5. 0, 1, 2, 3, and 4. So let's go over to this side now. Now, boys and girls, we are going to do addition using base 5. Read with me. Find the sum of 2, 4, 5 and 1, 2, 5. Okay, so we're going to put the numbers that should be in, we're going to put the 4 down in the ones column because that is where the 4 should be. See? In the ones column. And we're going to put 2, which is in the 5s column. And we're going to go with our next number, which would be 1, 2. And we have 2 in the ones column. And then we have 1 in the 5 column. Did I forget something? Oh my, I'm sorry. I forgot the plus sign, which is the same of finding the sum because we're adding. Okay, so let us go ahead now. 4 plus 2 gives me 6. Can anyone tell me what's wrong here? 6 was not invited to the party. We have to stop at 4. So that simply means that because we're doing base 5, we're going to have to subtract 5 from the 6. So here I'm going to use my squares to present these down here. And count with me. 1, count with me. 1, 2, 3, 4, 5. And that leaves us with 1. So what do you think we're going to do with the 5 that we just took away from the 6? We are going to place it over in the 5 column. Let's go up to the 5 column now and have the numbers. 2 plus 1 gives you 3. So let's put them on the chart. Count with me. 1, 2, 3. And now because we have 3 plus another 1, because we took that 1 from the ones column and brought it into the 5 column. So now we have 4. Let us count them together. 1, 2, 3, 4. And when doing base 5 or any other base, when you get your answer, you have to make sure that you put your 5. Because if you don't put your 5, then it is wrong. Now we are going to move on to our subtraction word problem. Now we are going to do subtraction in base 10. And with base 10, you're allowed to use more numbers. In base 10, you can use 10 numbers. And those 10 numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But the numbers that you are allowed to use, they must be less than 10. They cannot be more than 10. So when you're working base 5, there should not be any base 10. There should not be any number more than 10 in the problem or in your answer. So let me show you how you do subtraction in base 10. Read with me. The Obis store sold 347 trading cards in June. In July, the Hobby store sold 808 trading cards. What is the difference between the amount sold in July and June? And difference is just a nice fancy word for subtraction or take away. So that is what we're going to do. We are going to take away 808 from 347. And now, as you can see here, we have our ones column. Now, I'm going to show you how to do subtraction in base 10. Read with me. The hobby store sold 347 trading cards in June. In July, the hobby store sold 808 trading cards. What is the difference between the amount sold in July and June? And difference is just a fancy word for saying subtraction or take away. So when you see this word, just remember you're subtracting or taking away. That means you're losing something or you're giving something away. Let's go down to our question. Now we're going to subtract 808 from 347. Okay, so now I have a nice little poem that will help you when you're doing subtraction. So here we go. It says, more on top, no need to stop. More on the floor, go next door and get 10 more. Number is the same, zero's the game. Okay, let's go right ahead now. So this is a what? This is a more on top, no need to stop. So 7 from 8 gives you 1. And we are going to go over to this side. And this looks like more on the 4 kind of situation. Think of it like you're hungry and you're craving for your favorite snack, some cookies, right? And when you look in the cupboard, there are no cookies. So what do? You go to the store and you buy some cookies. So that's exactly what I'm going to do. I'm going to go over to here and I'm going to get 10 cookies. We're going to go over here and we're going to take our 10, and now this 0 is now 10. And now we have a more on top, no need to stop. So we just go right ahead and take our 4 from our 10. 4 from 10 gives you 6. And we go over to this side and we have a more on top. No need to stop. So let's go ahead and subtract. 1, 7, and we have 4. So our answer is 406 1. Now we are going to represent, I'm going to represent what I just did up here on the place value chart with the manipulatives. So in the first part we had 8 we had 8. So I'm going to put my 8 as squares. As you can see over here, our 1s are represented by squares and our 10s are represented by rectangles called longs, and the hundreds is represented by squares, larger squares called flats. So let's go ahead with our little tiny squares. That's what called. They're also called units. Now let's count 1, 2, 3, 4. 5, 6, 7, 8. And remember up here we had subtracted 7 from our 8. So now you're going to count with me and we're going to take away the 8. We're going to take away 7 from the 8 down here. So it's 1, 2, 3, 4, 5, 6, 7. And now we are left with 1. Let's go over to our other side. Remember how we said that? This was 4. There was more on the floor, so we went over to the store and we bought some cookies. We bought 10 cookies and we brought them over. So now we have a more on top, no need to stop. So we took the 4 from the 10. So let's represent our 10 on the place value chart. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 9 is not holding. Ooh, we're going to get some glue. We're going to put it on. 9. Now we have 10. So we're going to do what we did up here. We are going to take 4 cookies. We're going to eat 4 cookies out of our 10 cookies. So let's count with me. 1, 2, 3, 4. And then we have 6 cookies left. Let's count and see if we really have 6 cookies left. 1, 2, now we are going to subtract 3. We're going to take away 3 from 7. Now count with me. 1, 2, 3. And we have 4 left. Count with me again. 1, 2, 3, 4. And that's 4. Let's write our 4 down here. And we have 461. And always remember, you are supposed to put your base at the bottom. But here's a nice little thing about base 10. You don't always have to put your base at the bottom, because once you see a number and the numbers are within 1 to 9, then you know that it's base 10. But with the other bases now, you always have to put the base at the bottom, because if you don't put it there, somebody might mistake it for another base, and we wouldn't want that to happen. Now, this is almost enough for a lesson, but now we'll have Miss Smith with a presentation of our word problem in a diagram. Now over to Miss Smith. Thank you all for joining us.
That Miss Morgan just solved. We have a simple diagram of a pie chart representing the sales, right? So now we have the key for the pie chart. This represents the sale for July, which is equal to 808 cards that was sold, and this section represents the sale for June, which cards were sold in the amount of 347. Let me go again. This is a pie chart representing sales for the company of cards which were sold. This is a key for the representing the pie chart, representing the sales for the pie chart, which is the sale. This is the sale for the month of July, which was amount to 808, and this is represents the sale for June, which amounts to 347.